Hi, good afternoon, good morning, and welcome to the LoRa Edge webinar. My name is Mike Taylor, and I'm with Semtech Corporate Marketing. This presentation will be approximately 45 minutes long, and we will be providing an on-demand link to watch the webinar at your leisure afterwards, immediately to your email. So let's get started. So a little background on LoRa Edge. LoRa Edge leverages the LoRa Cloud Geolocation with an integrated Wi-Fi and GNSS scanning capabilities. The first product in the LoRa Edge platform is the LoRa Edge LR1110 transceiver, which significantly increases the range and the flexibility of geolocation solutions for both indoor and outdoor use, reducing the cost and the complexity of monitoring IoT assets. Pedro Pachuca, Director of Wireless Products for Semtech, will introduce how this product provides the necessary feature set to revolutionize your asset management solutions and offer more efficient asset tracking with the best balance between affordability, range, scalability, and low power. So without further delay, I'm going to hand it over to Pedro. Pedro?
Thanks, Mike. Hello, everyone, and welcome to today's webinar, LoRa Edge, Driving Smarter Geolocation for IoT. Thank you for taking time out of your day and being here with us. This is the agenda for today. We will start with a very brief overview about Semtech. After that, we will jump straight to a comprehensive overview of LoRa Edge. We will have a brief description of the problems that we are solving, then a quick overview on how LoRa Edge enables customers to develop a more affordable and simplified geolocation asset management solutions and market advantages. After that, we will conclude with a quick overview of the market opportunity for LoRa Edge and a brief summary. Just a quick introduction about myself. I am the director of the wireless products at Semtech. I started my career in the technology industry more than 20 years ago. My background is in system solution design, and I had worked for companies such as Freescale, Silicon Labs, and Renesas Electronics in multiple marketing positions, always focusing on end-to-end IoT system solutions. Let's get started with a quick introduction about Semtech. Semtech has nearly 60 years of experience designing and manufacturing proprietary platforms differentiated by innovation, efficiency, and performance. Semtech is a global leader in high performance and mixed signal platforms. We develop very unique and highly differentiated products based on a system level architecture with a strong expertise in analog design. So among these highly differentiated platforms, we have LoRa Edge, which is a new portfolio of products. The first product in this portfolio brings highly differentiated value to address a market need for an affordable and simplified geolocation asset management solutions. Asset management solutions are extensively used across multiple markets with a variety of use cases. For example, asset location. Asset location is required when people need to know the specific geographical location of an asset, such as locating a container in a warehouse, just for example. Asset traceability, people need to know the specific location of an asset from departure to arrival, such as pallet tracking in logistics. Geofencing is another use case where customers need to know if an asset is inside or outside a specific geographical area. One common example is cattle management, where customers need to make sure animals are not trespassing other properties. Another illustration for geofencing is in construction zones, where now customers are using tracking solutions to track power tools to make sure the right tools are in the right place and people is working in the right location. Another use case is asset recovery. For example, in a hospital, the personnel needs to identify where the medical equipment is so they can quickly retrieve the equipment for another patient. And finally, asset loss and theft prevention, where typically customers need to know if a specific item has been removed. All these markets and applications drive a significant demand of asset management solutions. However, existing products are far from ideal to fully satisfy the customer requirements and expectations. We understand that customers are frustrated not only because they are facing many challenges with existing solutions, but because they cannot scale up their businesses and realize the full potential of asset management solutions. Let's explore a little bit more on the specific challenges that customers are facing today, which are business and technical challenges. The typical deployment of an asset management solution is through a system integrator or a small service provider. The system integrator provides these services to companies such as shipping companies, fleet management companies, inventory control companies, just to mention some of them. The system integrator typically integrates a solution from multiple vendors, such as device makers, software developers, and the network provider. The system integrator is responsible to glue all these products to provide a complete end-to-end solution to their customers. So every contributor in this ecosystem faces some very unique challenges that need to be considered to provide an affordable and simplified solution. For example, the device maker needs to make sure that they offer a low-cost device that meets all the technical requirements in a relatively short time to meet tight schedules. On the other hand, the software developer needs to make sure that they have all the elements to make a quick integration of all the software components and provide easy-to-use user interfaces. And finally, the network providers worry about making sure the network is reliable, secure, and provides the proper coverage. The system integrator also needs to make sure that they have all the elements to put together a comprehensive solution which is cost-effective and reliable. We will explain later how LoRa Edge helps each member of this ecosystem to overcome their particular challenges. But before we go into that, before we go into those details, let's have a taste of the technical challenges so we can have a holistic picture of the problem that we are trying to solve. One of the complaints that we constantly hear from customers is that total cost of ownership is too high, mostly from the device makers who develop the hardware. Usually, they have to make an initial large upfront investment. They complain that today, to put together one of the most basic asset management solutions, which is a tracker, they use conventional technologies such as GPS, Wi-Fi, secure elements, transceivers from multiple vendors. The first issue or the first challenge is all the glue logic and design effort to combine all these technologies. Having a large number of components makes the solution more expensive and more complex. The second challenge, which is one of the most significant challenges, is the power consumption. This is definitely a deal breaker for asset management solutions. Existing products such as GPS or full-blown Wi-Fi technologies used for geolocation are extremely power hungry. This is intrinsic on how this solution works. For example, a GPS device collects the traditional GPS device, collects the signals from satellites, and internally demodulates and processes these signals to decode or to calculate the location, which is a power-hungry, compute-intensive activity. This makes power consumption too high for a low-power battery-operated system, and the same happens with the Wi-Fi system. Currently, customers are forced to constantly replace batteries, which is an expensive and daunting operation. Other customers implement expensive rechargeable battery systems which are not really adequate for tracking solutions that need to last months of uninterrupted operation. And lastly, security. Security is a major concern on asset management solutions. The possibility for someone to hack into a tracker brings potential liabilities to the system integrator, network provider, and the end customer. Based on a system level analysis and considering all the market and technical challenges that we just reviewed, LoRa Edge was designed from the ground up to overcome all these challenges based on three principles. Principle number one, single chip solution. So LoRa Edge offers a single chip solution that integrates a multi-GNSS scanner, Wi-Fi passive scanner, a LoRa transceiver, and to overcome all the security challenges, the LoRa Edge device integrates a crypto engine with a secure room to store the secure keys. This level of integration dramatically reduces the bill of material and simplifies development, reducing the total cost of ownership. Principle number two, a very unique and innovative device-to-cloud geolocation solution architecture. We practically redefine the paradigm of the conventional GNSS or GPS solutions, which are architected to solve or to calculate the location in the device itself. As explained before, in a conventional GPS system, there is a power-hungry, high computing processing unit which is computing or calculating the location of the device, which is a major disadvantage on power consumption. To overcome the power consumption challenge, the LoRa Edge solution uses a location solver in the cloud. That means that with this new device-to-cloud architecture, the device detects the satellite signals, the LoRa device detects the satellite signals, but rather than solving the location itself, it sends the data it captures from the satellites to the cloud solver, which in return calculates the location and returns the longitude and the latitude of the devices. Once in the cloud, the position data can be sent back to the device or to any other application platform, such as a tablet or phone, depending on the customer requirements. The whole system, device to cloud, has been designed from the ground up to be the lowest power geolocation system. The data that is sent to the cloud is a small payload with less than 50 bytes, which is all what the cloud solver needs to calculate the location. Our analysis shows that this new device to cloud architecture is 10 times lower power consumption than existing solutions. A similar architecture is for Wi-Fi, where the device reads the MAC addresses of the nearby access points and sends those to the cloud, where the location is calculated based on a location database. The third principle is rooted on high security. The LoRa Edge devices integrates a crypto engine which provides a unique secure room to store the secure keys. The secure room is only accessible by the crypto engine, and no other system in the device can read the secure keys. This guarantees that the keys are never exposed, providing the highest level of security. In addition, Semtech pre-provisioned the device with secure keys, which eliminates the need for the customer to implement a secure provisioning system in their manufacturing flow. And depending on the level of security, a secure room in a customer manufacturing floor, can cost millions of dollars in operation and setup. Back to the LoRa Edge, once the LoRa Edge device is provisioned with the secure keys are also sent to the cloud, so customers can easily authenticate the devices without having to expose keys at any part of the process. These three principles enable customers to develop affordable and simplified asset management solutions. Okay, let's take a deeper look at the technical details of the LoRa Edge LR1110. The LoRa Edge device has a single multi-purpose radio analog front end which supports 150 to 2700 megahertz. This allows GPS and Baidu constellations scanning and Wi-Fi passive scanning. In addition, the LoRa Edge devices support an ultra-low power LoRa transceiver from 150 MHz to 960 MHz. This practically covers all the ISM band worldwide requirements, and it is fully compatible with the LoRaWAN protocol standard. The device is also equipped with a crypto engine that supports hardware encryption and decryption for the AES-128 algorithm, which is required to support the LoRaWAN. In addition to the crypto engine, the LR1110 also provides a secure run in memory to store the secure keys, and only the crypto engine can interact with the secure keys, which are never exposed, enabling a high level of security. At Semtech, we take security very seriously, and to support a higher level of security during the device manufacturing flow, Semtech pre-provision every device with unique secure keys. Customers can take advantage of these pre-provisioned secure keys, or they can inject their own keys. One of the benefits of using the pre-provisioned keys is that those keys are also sent to the cloud to ease the authentication process and eliminates the need to establish a secure process in the customer manufacturing flow, which again can cost up to millions of dollars. All these capabilities are provided in a small 5 by 5 square millimeter QFN footprint package. Okay, so now let's have a deeper look on the geolocation Wi-Fi functionality. Let's explain a little bit more how the Wi-Fi passive scanning works. The LR1110, the LoRa Edge LR1110, can scan up to 32 MAC addresses from nearby access points. The Wi-Fi packet containing the MAC address is captured and demodulated to only extract the MAC addresses and the RSSI signal. So there is no data communication. The only thing we can do is to capture the Wi-Fi packet and demodulate to extract only the MAC address and the RSSI signal. Once the MAC addresses have been obtained, the LR1110 sends that data to the cloud using a small LoRaWAN uplink. The cloud solver uses a database and calculates the location. Once the location is calculated, the location data now can be sent back to the device or can be sent to another platform depending on the customer application. Again, this application platform can be a tablet, or can be a smartphone, or it can be even another cloud system. Okay, now let's have a quick overview about the GNSS scanning principle. The GNSS in the LoRa Edge LR1110 has two different modes of operation: autonomous mode and assisted mode. Assisted mode is the more power efficient and highly recommended to use. In this mode, the LR1110 captures the signal from the satellites and creates a navigation message which is sent to the cloud via LoRaWAN uplink. The cloud solver calculates the position, and once the position is calculated, the position can be sent back to the device or to another platform, depending on the customer requirements. To enable a fast locking of the satellite signals, assistant information is provided to the LR1110. This assistant information, such as initial position, current time, frequency error, and almanac updates, are provided from the cloud solver to the device. This enables the device to log the satellite signals in less than 2 seconds, which is a highly differentiated capability compared to the traditional GPS devices that can take up to 30 seconds. This enables a dramatic reduction on power consumption. The faster we can lock the satellite signals, the less power consumption that we take. So this is a highly differentiated capability with the assisted mode in the GNSS operation. So LoRa Cloud Geolocation Services automatically provides the assistant capability as well as the location services. For more information on LoRa Cloud, please visit loracloud.com. Is LoRa Cloud altogether, .com. So from a system solution perspective, and using a tracker as an example, a complete solution would look like the one in this picture. The final product, let's say we're talking about a tracker, will send the location data through the gateway, the LoRaWAN gateway, and will use the traditional LoRaWAN infrastructure network server and the application server. In this case, the application server is integrated with the LoRa Cloud services to provide the location of the asset. In the big picture, the system is relatively straightforward. Once the location data is sent via LoRaWAN, the location is calculated in the cloud solver for the Wi-Fi and the GNSS, and again, that can be sent back to the device using the LoRa infrastructure, or it can be sent to another cloud or another, application server. The system is very flexible to accommodate all the customer requirements. So one important aspect to understand about LoRa Edge LR1110 is the market positioning. LoRa Edge was designed from the ground up to overcome the power consumption challenges, and it brings a unique value when customers are focusing on low power, battery operated solutions that need to last for years in the field, and accuracy requirements are in the range of what is known as a standard accuracy, which is in meters. However, we do recognize that there is a portion of the market that needs high precision accuracy, and power consumption is not really a significant issue. These applications can be connected, permanently to the power. So in that case, when the customer is okay with the high power consumption, but they need the super high precision, using a high precision GPS, might be required. But when we see the big picture of asset management solutions, we consider that more than 90% of asset management solutions are in the low power, battery operated, standard accuracy category, and LoRa Edge is the ideal solution. Based on the positioning model that we just reviewed, applications that require low power and standard accuracy are the ones that highly benefit from LoRa Edge. Fleet tracking, agriculture, building and campus equipment tracking can immediately benefit from LoRa Edge. Ultra low power, single battery operated applications such as pallet and containers tracking can significantly extend the battery life for many years using LoRa Edge. LoRa Edge supports customers to implement all kinds of use cases for these applications, such as basic location, just to know where the asset is, traceability, geofencing, asset recovery, loss and theft prevention. When higher accuracy is required, customers need to make some trade-offs decisions between power consumption and accuracy. LoRa Edge can serve many of these opportunities, but careful consideration on accuracy versus power consumption needs to be evaluated. So Semtech provides a full-blown development tool where customers can evaluate and start production development. Several examples are provided for customers to evaluate the hardware capabilities, but also the cloud solver and also the cloud services. And depending on the regional frequency, and a specific part number is required for the development kit. There are three different part numbers for the three major ISM frequencies. So there is one part number for the 868 megahertz, one part number for the 915, and one for the 490. This corresponds pretty much to the frequencies in Europe, US, and China. And some other countries also benefit from these frequencies. All the documentation can be found on semtech.com and Semtech Developer Portal. So the product datasheet, user manual, and application notes are available to support customers to quickly evaluate and start product development. In addition, some specific notes like the geolocation precision, which describes the accuracy capabilities in multiple environmental conditions, is also available for customers. Okay, we are at the end of this presentation. Let's have a quick summary. LoRa Edge combines the power of GNSS, Wi-Fi scanners, LoRa transceiver, and crypto engine in one-stop shop to develop a more affordable and simplified asset management solutions. The very unique and innovative device-to-cloud architecture dramatically reduces the power consumption up to 10 times compared to existing solutions. And finally, the crypto engine, secure room storage, and the secure key provisioning enable customers to implement robust security, eliminating the need for external secure elements or expensive provisioning systems. Okay, so this is all from my presentation. I want to open the floor for Q&A. So Mike, back to you now.
Yeah, thanks, Pedro. Over the course of the presentation, we received over 50 Q&As, so thank you all so much for these excellent submissions. So let's get started. Pedro, Andres Ramirez asks, what is the autonomous mode and how does that work?
Well, in the autonomous mode, basically the LR1110 is capturing the data from the satellites without using any assistant information. In the autonomous mode, what happens is that LR1110 takes a little bit more time in order to lock the data that is coming from the satellites. So we don't provide any assistant information, but even in the autonomous mode, we capture the data from the satellites. Again, it takes a little bit more time. There are some calculations that the device needs to do, but then the data is sent back to the cloud in order to solve the position of or to calculate the position of the asset.
Okay, next question. Is the system required to use the LoRa Cloud server, or can anyone build their own location solver?
Oh, that's a very good question. Thanks for asking that question. The answer is that people can build their own solvers if they have the know-how and the resources. Anyone can build a cloud solver. So we provide a cloud solver so the customers, they don't have to reinvent the wheel over and over. So that is provided by Semtech. But again, if the customer, for whatever reason, they have a special way to do it, they can do their own solver, and the LR1110 will work, with that solver.
Okay, perfect. All right, well, in that case, Scott Suey asks, how does the LR1110 solution compare to using Wi-Fi module scanning periodically looking for SSID in access points, and then sending back to the cellular network using Cat M1 modules?
Well, one of the in terms of the modus operandus is similar. So we capture the MAC addresses, we read the MAC address, the RSSI, we send that to the cloud. The major difference is the power consumption. So compared to a cellular, in order of magnitude, we can perform exactly the same capability with a fraction of the power. So again, LR1110, the LoRa Edge, is designed from the ground up to be the lowest power geolocation system, not only for the GNSS, but also for the Wi-Fi.
Perfect. James Sioho asks, will the LR1110 be able to detect Wi-Fi 6 access points?
Yes, yes, it is capable for that.
Okay, great. Stefan Wanamaker asks, what degree of precision is to be expected with this solution, both outdoor and indoor,
Hey,
when you're tracking assets?
yeah, that's a very good question. The precision data that we provide is in terms of the outdoors, we can be in the 5 meter precision or accuracy for the outdoors. In terms of the indoors, that's a range. The indoors really depends on the access points, how many access points. So the field trials that we have done for the indoors, it shows accuracy from 5 to 20 meters using the Wi-Fi. Again, the more access points are out there, the more well mapped are those access points, the better accuracy. So, we are expecting that for an indoor deployment, many customers will position strategically access points and they will map those access points in an on-site survey in order to improve the accuracy.
Okay, so between 5 to 20 meters and then increasing depending on the number of access points. Okay.
Correct.
Next question, Theo Mayer asks, is it mandatory to use the Semtech GEO DAS server, or is it possible to have a private cloud application decoding the GPS data?
Yeah, so I think we answered that one before. Yeah, the answer is
Okay.
yes. Your customers can do their own private, cloud solvers.
Ankush Agarwal asks, is there any ready design using PCB antenna or chip antenna which can help me to create a design quickly? So I guess this is asking, what resources are available to create an application with LoRa Edge quickly that's available now.
Yeah, well, we are working on the design for the PCB antenna. It will be available, pretty soon. Today in the evaluation kit, we provide the, physical antennas, patch antenna for customers to do a quick evaluation. But there is a, PCB antenna design that is coming soon.
Ankush also asks, can the LR1110 be used in sniffing and broadcastings like BLE beacons?
That's a good question.
Okay.
We don't support now the beaconing for the VLE. That's a capability that is not supported today in the LR1110.
Glenn Laughlin asks, for Wi-Fi assisted with the precise and known locations of Wi-Fi access points, would the LR1110's location accuracy be better than quote-unquote standard precision?
I mentioned that today the data that we have seen on the Wi-Fi, again, is in the 5 to 20 meters. And again, depending on the number of access points. Again, from the Wi-Fi, the better, map we have from the access points, the better accuracy. So in the LR1110, we read the MAC addresses, but we also use the RSSI in order to improve the accuracy.
Next question, Saul Davila asks, if you have to send the satellite's information to the cloud solver, what is the payload size of that message? Just to consider LoRaWAN limitations and the maximum devices within a network.
Yeah, that's a good question. So, we mentioned a little bit on this that the data that is sent to the cloud from the device to calculate is only 50 bytes. So this is designed for low power in a LoRaWAN network. So yeah, the LoRaWAN network, the payload in the uplink tends to be, a small number of bytes. So we only use 50 bytes. Everything is packed in 50 bytes that are sent to the solver, and that's all what the solver needs in order to calculate the location.
Okay. Himanshu Kathuria asks, how much battery power is expected, or is necessary, I suppose, with the LR1110 if location is to be captured only once or twice per day?
Oh, that is just very, very minimal. I don't have the number. We publish the data sheet, so all this information is in the data sheet. But for a device that needs the location, once or twice per day, definitely the power consumption is very, very low.
Okay, now this is a question about LoRa Cloud, the business model for LoRa Cloud. The question is, What is the business model for LoRa Cloud? Is it free or do you pay per use?
Oh, that's a good question. So, in the LoRa Cloud, we have different business models. So we enable a consumption business model where customers can buy a number of queries. So, for example, they can buy, 500,000 of queries. They can use that in a month, or they can buy, 40 millions of queries. So depending on how many times the device is, asking for the location. So this is the consumption-based model. There are multiple prices. All the pricing information for the consumption-based model is in the loracloud.com right now. You can open an account and you can see all the pricing information. We offer also free tiers, for customers to evaluate the technology. What is coming is a consumption-based model. In the consumption-based model, we will offer services depending on the number of devices that you have deployed, and they will have access to unlimited queries on the GNSS and the Wi-Fi. But those services are coming in the near future.
Okay, great. And going off that point, yeah, we'd just like to welcome everyone on the call to explore the Semtech website further for our additional resources, explore the LoRa Developer Portal for all your development needs, and like Pedro said, there's a lot of great information on the LoRa Cloud website and related to LoRa Cloud and using those services. Okay, moving forward, good question from David Gerber here. Is it possible to calculate a rough GPS location on the device if the device is out of reach of a LoRa network? If so, how precise would that be? And then he says, I'm thinking of satellite communications such as Lacuna, where a device would require rough positioning to calculate when a satellite is within reach.
Yeah, it is possible. The LR1110 doesn't have any compute capabilities to locate the location by itself. So if the customer wants to do, localized, type of solver, they can do that with an external, microcontroller or an external MPU. That's not precisely the use case that we are targeting for the LR1110. In that particular case, power consumption will be very high because you have the engine calculating the location in the device itself. But if that is not an issue, customers can explore that too.
Okay, perfect. Next question, this is from Nancy Taylor. What application is currently the most popular or widely used for LoRa Edge, or I guess what do you expect to be offer the most market value for the LR1110 going forward?
Oh, that's a good question. We have many customers now designing LoRa Edge in transportation and logistics applications. So, cost in transportation and logistics is pretty sensitive. So anything related to pallet tracking, container tracking, all kind of, asset tracking in transportation and logistics, that's where we see a significant design activity and opportunity for the LR1110 LoRa Edge. We also see that for, fleet management, for vehicle fleet management. That's another big opportunity where customers are exploring LR1110.
And then I guess following up to that, David Van Zuridam asks, for these different applications, would it be possible to use the LR1110 and get accurate measurements for solutions deep underground? So possibly underground warehouses, applications like that.
Well, if we are talking about the Wi-Fi, yes, that can be done. For the GNSS, there is no satellite signals underground. This is just how the GPS works. But for the Wi-Fi, if there are access points, on the basement, things like that, yes, you can deploy, tracking solution using the LR1110.
All right, thanks so much, Pedro. We are actually at time, so we're going to end the webinar here. We'd like to thank you all for joining. A recording of this presentation will be provided to you in email correspondence coming later today. Thank you all so much for joining. Have a good rest of your day. Thanks.